This video explains how to use Shiphonyer to create a simple rectangular panel, with or without rounded corners, and with or without edge banding. For this, you should use the Create Panel command. In order to activate the Panel Creator command, you must first be in the assembly environment. As you can see, this is a zero document environment. And the only thing you can do here is start the Create Module command. From there, you can choose whether you want to create a new component, a new product, or a new panel. I recommend starting with Create New Component, for the simple reason that Create New Panel only creates an environment for making panels of arbitrary shapes, like this one shown here. To demonstrate the Create Panel command for a rectangular panel, we will start by creating a new component, and naming it, for example, Drawer. Here, open the Shiphonyer tab, and now the Create Panel command becomes available. When you click the command, a window opens with many available options, and we will go through each of them one by one. The central area represents the panel itself and its properties. First, we give it a name. In this case, we will simply call it Panel. The code field is inactive, and you cannot enter any value. It is intended for integration with an ERP system, from which this value would be inherited automatically. Next, we define the panel length and width in millimeters, let's say 1200 and 600. The next three fields are used for selecting the material for the panel. The available materials are those you have previously defined as valid panel materials categories in the database materials setup. Let us select chipboard. You will see the thicknesses that were defined for that material. And for chipboard, those are 10, 18, and 25 millimeters. Let's select 18 millimeters. Next, you have the option to select a design. All of these options were defined in earlier steps, while setting up the database, so they can now be used for panel creation. The add-in comes with some predefined materials. Values from 1 to 15 represent wood imitations. 30 to 45 represent stone imitations. And 60 and above are solid colors defined using RGB values. Let me select, for example, bronze expressive oak. Once you have selected the panel material, you can define the edge bands for each side. By default, the selected edge bands are made of melamine, and currently we have these three options set in our project. The system is created so that if a design exists both for the panel and for the edge band, it will be displayed automatically. However, as you can see, the edge band with design 12 does not exist, which is why these fields are empty. This forces you to select the appropriate design for the edge band. Here we will choose Cost Evoke Oak. This edge band is available only with a 1 mm thickness and a 19 mm width, which matches the panel thickness. As you can see, the Create button is still inactive because all required fields must be filled in. We will assign the same edge band design to all edges. Now the Create button becomes active. But before creating a panel, we will set the texture orientation. Check the checkbox for texture orientation to choose whether the texture runs along the width edge or along the length edge. We will select along length. We click Create, and the first panel is created. We should now close the assembly without saving. Let's take a closer look at the panel we just created, located in the component environment. When we measure it, the length is 120 centimeters, or 1,200 millimeters, exactly as defined. And the width is 60 centimeters, or 600 millimeters, also as we entered. Notice that the design texture is oriented along the length. If we examine the file structure, we can see that it consists of the panel itself and 4 edge bands around it. This symbol is familiar to Inventor users. It indicates that the part is adaptive, meaning it adjusts to another element. In this case, the edge bands adapt to the panel. What does this mean in practice? The command is designed to create a panel this way, as a rectangle. This purple color indicates that the profile is not fully constrained. It requires 8 dimensions for full geometric definition. And that means the geometry is not fully constrained, allowing you to modify it if needed. And because there are no constraints applied, you can, for example, select an edge and move it inward. If you click Finish and then Update, you will see that the edge bands follow the new shape automatically. The only thing you must not do is delete sketch entities and redraw them manually. If you delete a line and draw a new one, the edge bands will no longer be visible, and the command will fail, resulting in an error. Although the command is designed for rectangular profiles, you can always modify them to suit your needs. Using the same command, we will now create a second panel with rounded corners. We name it Panel 2. And for this one, the length will also be 1200 mm and the width 600 mm. To make simple corner rounding, we only need to specify which corner will be rounded and set the radius value in the corresponding box. Let us select the 18 mm chipboard. Since there is no design for the edge band matching the chipboard, we chose a different one. We will select Design 7 for all edges. The Create button becomes active, but first we need to define the radius. Once you select the radius option, the Create button becomes inactive again. That is because the radius value is 0. And the minimum allowed value for the radius must be greater than 20 mm. We will enter 50 mm. This section is now inactive. The reason is that the same design from here is automatically applied to the rounded edge. This is because the edge banding machine follows the edge continuously, along the straight edge through the radius and onto the next edge, using a single edge band. If you do not want one edge to have the edge band, simply deselect Option has edge band for that side. Now we click Create. This is what the element looks like. There are only 2 edge bands. And the panel includes a rounded corner. If we enter the sketch, you will see that the rounding is done at the sketch level. The fillet command was not used. You can further modify the radius or constrain it with a dimension. For example, we can set it to 150 mm. After clicking Finish and updating, the edge band automatically follows the new contour. You can now move the panel to any desired position. Also, by using constraints, you can assemble elements into a complete structure. Let's look at another example of how we can use the Create Panel command. We will now create Panel 3 and select the Part option. When this option is selected, no edge bands are created, only the base material. Let us set our panel like before. Length to 1200 millimeters and width to 600 millimeters. Let's leave chipboard with 18 millimeters thickness and use the Vengi design. After clicking Create, the element is created as a part. And there are no edge bands on it. This element can be further manipulated. It is useful for elements such as back panels, where you may want to use chipboard or an HDF panel, used as a part. Now let's look at how enabling and disabling individual edge bands works. When you start applying a radius, the system disables edge bends in the counterclockwise direction. If you select the radius to be here, this edge will be disabled. The back edge is considered the main edge, and its properties are used for the edge band. If you disable another edge, the edge band will continue along the remaining active edges in sequence. Let us create the panel with all 4 rounded edges. We set the radius values to 150 millimeters for all 4 corners. As you can see, only the top field is active. That will be our edge band, and we won't change its settings. For the panel's name, we can use Panel 4. The material will again be 18 millimeters chipboard, with dimensions of 1200 by 600 millimeters. Now we can click the Create button. The result is a panel from chipboard, and 1 continuous edge band going around it. Finally, let's look at what happens behind the scenes. In addition to creating the 3D model, the add-in automatically creates 3 user parameters for each panel. Those parameters are thickness, length, and width. They are created based on the data we entered in the form. These parameters are automatically marked as export parameters, which is Inventor's standard functionality. Which means if you open iProperties, then Custom Properties, you will see these values listed there. Also, as you can see on the iProperties for the panel, the add-in calculates the actual cutting dimensions for the panel by subtracting edge band thickness where that is applicable. The type element means that this is a part. When talking about edge bands, we can see iProperties for each of them. The length of straight edge bands is obvious, and in our example it is 1198 millimeters. When we have rounded edge bands, the total length is calculated by adding all segments. In this example, 1773.4 millimeters. That is the length of this straight edge, this radius, and this straight edge. These values can later be used in the bill of materials to obtain exact material quantities.